Turn Right Machine Works. My name is Keith. Today I want to introduce you to a old project, and you know, we're just getting up to speed on this, so you're actually coming in at the right time. We're building a TV elevator or a big screen elevator, meaning this elevator is going to be located in an upstairs closet, and the overhead ceiling will open below it, and the TV will gently be lowered down into the room for viewing in that room, and then they'll be able to retract and go back up into its storage space. Now this elevator is going to be able to handle a 65 by 48 inch viewing screen. That's going to be gauged by its storage area. And so here's a few things that we've procured already and what we're doing as far as the progression and project here. This here is a look at the lead screw that I'm going to be using on the elevator itself, and this is a 3/4 inch high lead. And the reason why it's a high lead is because the advancement of travel in one revolution is greater than the normal appearance of 8 threads per inch. Now you can see the increased angle. Now the reason why it's a high lead is because there's more than one thread going around on here. This particular one has got 4 threads. Here's the nut, and I took the Sharpie and I just highlighted where the chamfer is on the start of each of those threads there. Alright, now we're going to screw this on here and get it started right. We'll just go flush right with the end there. Alright. Now here's the set screw that holds the nut itself into this flange assembly, and we're going to go ahead and give it one rotation around. And there you see the set screw, and you see our advancement right here is 1/2 inch. So basically they're using a simulated 8 threads size, but putting 4 leads in there doubles or quadruples the travel. So instead of 1/8 or 1 revolution for every 1/8 of an inch, it's 4/8 or 1/2 inch travel. And if we advance this up one more turn, we got a full inch. So this nut here, we know that 2 revolutions per inch. Now here's the specs on the DC motor we got here. So it's 90 volts DC, 3/4 inch horsepower, and the RPMs are 1750 RPMs on this thing. Okay, motor's going 1750 RPMs, and this is the reduction gearbox label here. We're running 10-to-1 on this 90-degree gearbox, so that's pretty easy there. That means that 1750 is actually going to be going 175 RPMs per, 175 revolutions per the 1 minute. And we know that it takes 2 turns to turn that lead screw 1 inch. So we divide that by 2, and that gives us 87.5. 87.5 divided by 12 equals 7.29 feet in 1 minute. And that's the projected timing on this elevator. At least this is what we're playing with right now. And here's a little sketch that I did up here. Basically, here's the downstairs floor here. Here's the big screen right here, 65 by 48. And we have about a 14-inch space between upstairs and downstairs. But we got about 76 inches to tuck that away. That's 6.3. And there'll probably be a little tiny bit more travel to fit up in there and create door covering and stuff like that. So we should be in the realm of actually 1 minute to completely lower this into position or completely retract it on up into storage space. Okay, this is a looking down view of pretty much what we just made, tacked together on our table there. And we got this frame, this 1-inch box tube. We got these 2-inch box tube verticals, small section cut in there, and then the support that comes around here. And instead of this right here is actually our lead screw nut in place on this drawing here, but the plate actually has the 4-bolt flange bearing mount there. And these two, of course, these are the two flanged cam rollers that will be guiding the center section up and down. And these right here are going to be wear blocks or the track for the rollers. So the flange will hold the side-to-side motion, and the rollers will handle the vertical. There'll be two sets, 32 inches apart from each other, so that they'll handle the sway as well. Now here's looking down, the same thing on our jig here, and these are the cross supports here that will be going up and down the box tube right here. And we're pretty, we've been practicing getting that cut. We're getting a nice gloss finish on there, so our cut is pretty close. And I mean, we drew this out, we cut that, we tack all of those in, and these are almost holding themselves in here. All right, that's pretty close fit. I like that. All right, these are made up to have clearance to bypass this by about 1/4 inch or so. Everything will be traveling straight up and down. And this is the only traveling part, up and down the lead screw. Everything else will be open inside this area right here, the rollers themselves. Now basically we've got our outside frame and structure for the actual tower or the carrier, the housing, the enclosure for the elevator. And this is, I've got this set up because we're kind of planning out our rods going over and our 90-degree gears, which those sets should be coming in here this next week. And we're kind of just taking some measurements before this frame goes down to location for fit up and any carpenter work that needs to be done down there in place. Well, for the most part, this project has pretty much been up in the brain here, and the plasma cam does give me the opportunity to go ahead. I mean, I am having to actually program and create some parts, but it's also so simple to use the software and create the drawings. So I am drawing this up as I go along. Now there's going to be more than just the plasma cutting, but there's going to be some welding, there's going to be some lathe turning, there's going to be some mill work, there's going to be almost every aspect of Turnright Machine Works capabilities into this project. And we put it off long enough, and it's time to put some get her done into it. So get her done.